All right, I'm recording now.
If you want to do it right, you could do shaky cam.
Shaky cam. Yeah, I kick the stand once in a while.
Yeah.
All right, introducing Doug.
Welcome everybody. Thanks for coming out this evening. Tonight I'm going to be talking about rapid prototyping with Perl. It's actually one of the features of Perl that people talk about a lot, which ironically I hadn't used that much because I'm a Perl programmer, so for me the prototype and the actual end product kind of merge together. So, you know, I had never actually just prototyped something that I knew ultimately wasn't going to be in Perl at all, but I wanted to do it in Perl first because I could do it a lot faster to see if it was going to work, and then later I would translate it into the language, in this case C#. So I figured, hey, first time I've actually done it, I might as well talk about it. So, okay, we'll just talk about rapid prototyping in general. Perl's obviously not the only language you can use for it. Basically, you can reduce risk because the sooner you can generate a prototype and a proof of concept and show that an idea is going to work, the less risk there is, the less code and the less programmer time has been spent on it, the better, you know. And if it's going to fail, you know, because let's face it, things fail. You'd rather fail really fast up front, yeah, this is not going to work at all, rather than having a whole team dedicated and, you know, have it written in C or whatever and have thousands of lines of code that you have to toss out because it's not going to work out. All right, users are better at using the reacting than at creating specifications. So this is also starts to merge into process a little bit, you know, the whole Scrum, Agile, you know, whatever. Basically the idea being that if you can prototype something quickly, get it in front of users, they could go, yeah, I like that, or no, I don't like that. Whereas if you just go to them and ask them, hey, what do you need? You may get some useful information, may get misinformation, you may get asked for a whole bunch of features they don't actually need. It's kind of, you know, a lot of things can happen there. But when they've actually got something to look at and react to, it's more interactive that way. Obviously, they can be usable and evolved, which that's been like 99.999% of all the programs I've ever written turned out to be something. Or I never finished because I ran out of time, let's face it. Just keeping it real. All right, obviously my most common use case, but as I mentioned earlier, this is the first time I've actually not done that, so I figured I'd talk about it. Okay, so basically, I've always wanted to be a game developer, although doing it professionally, I've heard is not great because it's a game for young guys because they like to work you to death and burn you out and throw you away. But anyways, in my not so copious spare time, I decided I'd start dabbling in it again. I've done it different times over my lifetime. So this time though, I wanted to pick something that I could finish. So I'm like, okay, match 3 games, those are really popular, relatively simple concept, not that hard. I can finish this. Dang it, I still haven't, but I can finish it. So basically, just to give you a premise so you have some idea of what I'm talking about. It's going to be a match 3, which I'm assuming everybody, raise your hand if you don't have any idea how match 3 game works.
Maybe call it Candy
Oh,
Crush.
okay. All right. There are
Just say Candy Crush.
Oh, well,
yeah, like Candy Crush. Basically, the idea being if you have 3 things or more in a row that are the same, they disappear from the board, random new things drop from the top, and you get something for it. You get a
Is it
score.
like Tetris or something?
Oh, well, it's
Sounds kinda like it.
somewhat similar to Tetris, but instead of manipulating shapes, you just, what you would do is like swap, like I would swap this green one here with this white one, and then I would get these four.
Okay.
And then these would disappear, these would drop down, and new stuff would drop, random stuff drops from the top. So actually, I'm glad I asked that question. I shouldn't
Yeah.
assume everybody knows what a match 3 game is. So that's just kind of an overall term for the genre. There are a lot of variations on the theme. My variation was, you're gonna have a wizard on each side, and those represent the traditional elements, you know, earth, air, fire, water. I've also got life force and spirit, so I'm cheating a little bit, but depending on which ancient culture you listen to, they had variations on whether there were 4 or 5. This is going all the way back to alchemy, but anyways, I digress. So you'll match these, you'll get the elements, they'll be in the upper right and left-hand corner, a little just table that shows how many of each kind you have, and then you'll be able to cast certain spells once you get the certain number of all the different colors of elements you need. And then you'll cast a spell, you know, a fireball will shoot across the screen or whatever. You know, that's the hand-waving part that I haven't finished yet. So. But that's the concept. Everybody kind of clear on where we're going with this now? Okay, cool. So basically what happens is, at the beginning, I just tell the game, just randomly generate it. You know, literally, it's just random. Just give me whatever. So you can tell already, I've got a match here, I've got a match here, which I don't know why I'm bothered and straining my eyes. I outline them there so you can see them. Now obviously you don't want to start the game with matches because, you know, what's the logic then? Do you just give it to the players for free? Well then that's great for the first player, but what about the second player? He doesn't get any. So really what you want to do is make sure there are no matches before you present it to the player, or players in this case. Does that make sense to everybody? So the other thing, which I won't go into tonight, but the other thing that you also want to do is make sure there are potential matches on the board. Because you also don't want a dead board where you can have one where it has no matches and has no potential matches. And if that happens, the logic's going to be basically just brute force dumb. Just generate me a new random board, and then I'll, you know, clean it up. So far so good. So, starting with this board, I don't want those matches there. So, here's the problem. I want to match 3 elements of the same, and this is a slight variation on the genre that I have. I want to match 3 elements that are contained in a list of valid matches. And I'm actually going to reward the player. So in other words, if they have a spell that takes fire, air, and earth, I want to match that in any permutation, any order that those 3 are in. If they spot that and they make a match on that, I want that to be a valid match, and they'll actually get double the number of elements because I figure it's cognitively, it's harder to match 3 different things than it is to match 3 same things. So that way you naturally give the player a reward for, you know, spotting something that's harder to do. Plus it adds a little, you know, variation to the game. If I'm going to do a match 3 game, I want it to be at least a little different than all the other millions and billions of match 3 games out there. So anyway, that's my variation on it. But as you can imagine, this is somewhat hard. This complicates things a lot by saying, not only matching 3 things that are the same, yeah, it's not so bad. Matching 3 things that are different and can be in any possible order, yeah, that's a little more difficult. So this was my first attempt at the solution. I went on and on and on with loops and logics and checking and looking ahead and going, okay, so far I have 2 of these. Is the third one, you know, a valid one? If it is, then, you know, then hey, I got a match. If it's not, I got to toss everything out and start over again.
And I assume too, you also have to start, the starting board also has to be aware of that, so you don't start with those matches already being there.
Yes, exactly, and that's where I'll be going next, but you're absolutely right. Yeah, this was the result, was basically what I ended up with was nasty, horrible. I hadn't looked at it for a few months, and I looked at it a couple months ago because I wanted to start working on it again. I already knew it had bugs in it, it had corner cases, and because this is random, of course you don't catch those right away. You gotta hit those corner cases where you go, wait a minute, that didn't do the right thing, you know. So it was a buggy mess. Any questions so far? Everybody good with that? Okay, then it hit me. I'm like, dude, I'm a Perl programmer. I know regular expressions. This is a regular expression problem. If you think about it, it really is. I'm trying to match things, you know? It's like, it doesn't really matter what the things are, trying to match things. This is a job for regular expressions, and then you guys have probably seen this quote or variations of this quote. Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have 2 problems. This is an exception, in my opinion. No, really, it is
Well,
an
that's my
exception.
first thought is you're prototyping, which means you're talking about my future's going to be a different language. Did you worry about marrying yourself to something that might not be strong in your language?
Well, I had at least explored enough. I did enough research to realize that the regular expressions, because I had done some Java work here, I'd done enough C# that I, you know, had a good feel that it would probably work. The good thing is because almost everybody has adopted Perl regular expressions, or at least they're like 99% compatible. You know, for the common cases, they're quite compatible. So I don't know exactly how compatible C# is with Perl regular expressions, but all I know is I have not run into any problems. I've been able to just code stuff like I would code it in Perl, and it works fine. So, you may or agree or disagree, but in my case, this turned out to be, spoiler alert, I'll show you later, but so much less code. It actually worked the first time, and it makes a whole lot more sense. Now, I will make the case that a lot of times people use regular expressions where they don't make sense. I actually was a contractor who was fixing a program with 0 comments that was written by someone who had discovered regular expressions in Perl, and that's how they did everything. It was, I have never seen anything like it before in my life. Yeah, so I had to decipher it all, and it was quite the chore, let me tell you. But in this case, I think it actually does make sense.
Is that what prompted the shirt?
Obligatory. Actually, yes. I wanted the shirt anyways, but I'm like, I
Yeah,
only
it's
have
a
to buy this
no-brainer.
shirt. 'Cause it comes from this comic.
Oh, okay.
So it's a business expense.
It's business.
I like the way you think. You need to write that out.
Foreign got
So-
that shirt way back in the day.
Anyways, just a little story there about why regular expressions are wonderful. Okay, well now we're going to improve it. Now we've got ASCII. The next thing was that all of my elements had unique starting letters, so it was literally a no-brainer to just take the name of it, truncate off the first letter, and there you go. I've got basically the same grid, and now they're letters. They're ASCII, so now I can start doing regular expression things with them. So kind of makes sense. WW for water, which is the blue one. A is air. E is earth. L is life force. That's the white ones. and S is for spirit, which are the purple ones. And all those, if you, total trivia, but I actually used the ancient symbols and all that stuff. I wasted a lot of time doing actual research on
Did some
what the
Googling of
symbols
it.
were.
The fun part.
It actually was fun. It was pretty educational, but anyways.
Very interesting.
Yeah,
Thank you.
I won't bore you guys with all of that. So then I thought, okay, I know that I want to match 3 different things, but it's not that simple. I have to have every permutation that those things could be. So if you've got, like I said earlier, fire, air, earth, it could be earth, air, fire, or it could be fire, earth, air, or yada, yada, yada. You get the idea. They could be in any order. So basically, I'm not going to talk about this. This is left as an exercise to the attendee. But I'm giving the source of where I got the algorithm to generate the permutations. I just did this because, for me, it's a black box. I don't really care. I just want permutations. This wasn't the part of the program which somebody in the Perl world called yak shaving, where you get distracted by doing all these other little things. This was something I didn't want to be distracted by. I just wanted to get something that worked. It's in The Art of Computer Programming, Volume 4, which according to the source isn't even out yet. So, anyways, I don't know how much further he's going to get to. He's getting up there in age. So then I need to turn the permutations into regular expressions, right? So that I can then match against that grid in 2 dimensions. Does that make sense so far with everybody? That's a high-level logic that I'm going to use. Now I'll actually show some code, and actually first I'm going to run this. And I have to sorry, this VGA resized everything for me, so now I've got to make it legible again.
Knowing where you work, I think I want that application you have on your desktop to go back to HBAS.
Yeah, that's not nearly as interesting as you might think. Okay, so this is my proof of concept running. I'll show you first what it does, because I find that's always more useful to see what it does first and then look at the code. So there's my random grid, which, since this is in Perl, I don't bother with any of the graphical stuff. I just generate a 2-dimensional array full of random letters. Here are the permutations where I came up with 2 different, one I just called Fireball and one I called Ice Ball. Who knows if that's what they'll end up being in the actual game, doesn't really matter. It just proved my point that I could have arbitrary combinations and that I could match them and it would work. So those are the permutations. This right here is the regular expressions that I end up with. You can see these are pretty standard. E, I can have 3 to 8 because it's an 8 by 8 grid, right? So the minimum is you need to have 3. The maximum you could possibly have is 8. So those are all simple. The interesting one is this one here. You can see all I did is I generated the permutations, I put words between them. I mean, how simple is that? That used to be, you know, tons and tons and tons of lines of nested loops doing that kind of logic to figure that out. And now it's like that much text. To me, I was just like, this is wonderful, this is great. So does that kind of make sense to everybody? Everybody know enough about regular expressions to understand? Just means this is valid, match, or if it matches this one, it's valid, or that one. And you notice it's just rearranging the letters. So it's just taking these permutations and putting them into a regular expression with ors.
Forgot
Make sense?
the question mark at the beginning of each thing, that's a non-capturing group, is that what that means?
Yeah, this is actually added by Perl. I didn't actually put that in there. You'll see in the code. When I'm printing this out, this is the way Perl sees it by default. It's, you know, it's almost like it's decompiling it when it prints it back out again, and that's why it's got it, yeah, that's non-capturing. But this inside is capturing, because I do want to actually capture matches, right?
And then what's the colon after the caret?
That's just part of the whole thing that symbolizes that this is a non-capturing group. Yeah. So anyways, yeah, don't really worry about this too much, because when you see it in the code, you're not even going to see those characters. So we'll page through it. And then what I decided, oh, hey, those that went off the screen are the coordinates of the things that match. And then I made a lowercase. So you can see right there, I've got 4 L's in a row. I've got 3 E's in a row. And then basically just keep cycling through. I'll see if I can find one of the, oh yeah, here we go. EAW. So right there, you can tell it worked. It identified one of them that was not 3 of the same, it was 3 different things. And just SSS, obviously that one matches. And it just keeps doing this in a loop until we finally don't have any. Sometimes, the good thing is this is blazingly fast. Also, that was like an unusual number of times. Usually it does it in about, I don't know, less than 10 times. Sometimes it'll go like to 15 or something iterations. But then finally I get a board where, you know, everything is
The last one
cleaned
has a
up.
fireball in it though.
I'm sorry?
The last one had a fireball.
Oh, yeah, I think I've got like a one-off where it's not always displaying the final board. But again, that's because this was a prototype and I only made it work well enough to where I knew it would work. I didn't like debug every little odd thing that, you know. So yeah, it still has a few bugs in it, but the important part is the actual code doesn't and actually works. And this saved me
You were to
a
learn
ton of time.
You don't have to write massive numbers of loops.
Exactly,
You do it
yes.
with regular programming.
Yes. So let's go back to the code then. Is that large enough for everybody? Yeah, I think so. All right, so most of the stuff is just a lot of boilerplate. Again, this is a black box. When we get to it, I'm going to totally gloss over it because I have not taken the time to figure out how it actually works. It's pretty dense code. And that's not really the point of the talk either. So I call the whole thing the ether because that's where things exist. So that's why it's called ether. These are my possible elements to choose from. And then I've got my regular expressions. These are my standard ones. And the reason why I broke these off separately is because these will be determined at compile time in the C# code. These are at runtime because as part of the game, you'll build up as you level up your wizard and all this stuff, you'll build up your list of spells. So you'll actually get to pick which spells you take into a battle. So I'm going to limit you on the number of spells because you don't want like, 20 spells or some ridiculous thing. So I'm going to limit it. So you'll pick at runtime what the letters are that it's going to match against. So I wanted that to be a separate set. So that's why conceptually I was just thinking ahead. Here it really didn't matter for my prototype, but I was kind of thinking ahead where it's like, yeah, I want those two things separate. Does that make sense to everybody? So these are just matching the sames, all the sames. These are the differences. And I could put in anything I want. And it doesn't even have to be 3. It could be 4, 5, 6, up to 8 if I wanted to. Although, obviously, with diminishing odds of actually, finding and it was such a thing, or even having it appear on the board. So this right here is just generating the random grid that you saw, right? That's all I'm doing is two-dimensional array, int random. Any questions, Sarah? I think that's pretty straightforward. And then this whole print ether is the thing that was spamming all the output. I just generously had prints through it so I could see what it was doing. And then here's where I do my permute, and then I have a stringify routine, which we'll look at in a little bit, because remember, right now I've got it as a character array. I really need them as strings when I match regular expressions against them. So I basically squish them all together into one string. Although, again, Perl doesn't make a distinction between a string with one character or a string with many characters. You know, it's just, it doesn't actually have a character type. It's just, in my case, they're single character strings, two-dimensional array. So, then you can see that that's where I'm joining on my regexes, right, with the alternator, and then I'm wrapping it in parentheses, and then I'm pushing it onto the list of regular expressions. And this print right here was what was giving Perl, when you're printing the regular expressions, is actually adding all that extra stuff. It's showing you how it views the regular expression, not necessarily how I put it in exactly. Because you notice nowhere do I have question marks or hats or colons in any of this. So then I basically get into my main loop where, you remember I said I've got to just keep doing this while there are matches, right? As soon as I take an iteration through the loop and I don't find any matches, hey, I'm good. Although, again, this is minus the logic that I said where you need to check that you have potential matches. I haven't done that part yet, so that's missing logic that I obviously have to add. But I've done a little bit of work on that on the C# side of it. Haven't finished it yet, but I've done a little bit. So basically, I'm going through, I'm not going to explain line by line, but this is what finds the matches. And basically what I do, here's where I'm lowercasing the matches. And the cool thing about it is, since strings are zero-based and arrays are zero-based, when I match and I do a capture, I can get the start and end values of that match. Guess what? Those numbers exactly match the indices of where that character resides in the two-dimensional array. So really, to sum all of this up, and I'll get into a little more of the code later, but to give you an overall picture of basically what it's doing, is it's squishing the string together, both in rows and in columns, because I've got to do it in both dimensions, looping through, matching, matching, matching. If it finds a match, it wants to grab the indices of where that match occurs, where it starts and where it ends. I can then, the reason why I want that is I actually don't care about the letters themselves, or the string or whatever. That's not important. What I need are coordinates, right? Because to bring this full circle, we're talking about a game. All of those game objects have coordinates, right? So that's really what I want, because how else do I, destroy them and take them out and give you points? I do that all based on coordinates, not on the string name of it or anything like that. It's all coordinate based. So that's basically what it does. Again, I'm just printing it again. This part does what it says. It removes the matches. This spawns elements, which basically just inserts wherever you took out. Like if it was like in the middle, it has to move everything down and then put new random ones at the top. And that randomness is, and the moving, is what causes you to have to loop through this, because just because you got rid of the first set of matches, by moving everything and adding new stuff at the top, you may have just generated new matches again. And in fact, as you saw, I did. So I have to keep going, keep going, keep going until there are no matches. Everybody with me so far? I know I was talking kind of fast there. I'll make sure that makes sense. So that's basically it. This is the, from do to while, that's the bulk of the actual program itself. Now, again, for your viewing pleasure, you will see why I'm not even going to begin to talk about it. This is, I cut and paste this from the link that I showed you earlier because, yeah, it's blazingly fast. It's wonderful, of course. It's, you know, in Newth's books, so it's got to be good. And I'm like, yeah, it's a black box. I don't care how it works. It just does. And I can attest it does. I just pasted it in there. It works great. So that's the thing that generates my permutations. Oh, and I also put in the credits so that a year down the road, when I still haven't finished this project, I can look back and figure out where the heck I got it from. Okay, so the find matches. You notice first we've got a column search, and then we just loop through each column. We basically loop through each character and just concatenate it into this string. And there's better ways I could have done this than that. That's pretty sloppy actually, but again, it was just proof of concept. If this was a real Perl program that I actually wanted to keep, I would clean that up. But, so then it loops through, once it's got all the string put together, then it loops through all the regular expressions because you've got a whole bunch of regular expressions that you're going to match. Good thing is though, again, regular expressions are blazingly fast. I mean, this just goes like that. It's really, really quick.
What is dollar, pound, plus?
I'm glad you asked that question. Dollar, pound plus and minus are the match positions. So that's basically, those are the indices of where the match is. The plus being the start and the minus here being the end. So I think I've got that right. Might be backwards. Little while since I wrote this, but I'm pretty sure that's
the end of matches.
What's that?
At plus is the end of matches.
The end of matches. Okay, I did have it backwards then,
Yeah.
because I thought about that for a second. I'm like, wait a minute, that doesn't sound right. Thank you.
Dollar pound plus would be the last index of the end matches array.
There you go.
Should
So
use
yes,
English.
what he said. So basically, again, I don't want to get too bogged down in this because really the purpose of this talk is not to talk about the code so much as the principle of well, number one, I guess even this is kind of random and may not fit in with the rest of the team, but just the fact that I took some time off where I wasn't working on the code, I came back and looked at it, realized the code I had was horrible, which I'm sure everybody's done, but then I thought about the code in a completely different way. I suddenly, I don't know what it was, something in my subconscious just went, wait a minute, this is all about regular expressions. Why am I doing this the hard way? And then once I did it, it was just, you know, boom, it just flew from there. And this is the part that changes the range, because basically I'm getting a range here. I've got the start and the end, but I want each individual coordinate in the middle. So that's all range to coordinates does. This gives me the coordinates back. And those were, you remember when I was showing you the output where it had all the, 1, 0, 2, 0, 3, 0, that's what comes out of this. And then I do the same thing with searching through rows. And this is the thing that, just gives me the actual coordinates. It starts at the start, ends at the end, and then it just iterates through and just goes, well, I know where the start is, I know where the end is, so I just keep going until I hit the end. And again, there's a lot better ways I could have done this. This was just the most straightforward way of doing it without putting too much thought into it. And then this is the part where it actually removes the matches. And let's see if there's anything. Yeah, you notice here, I basically keep track of how many things were removed out of each column, because that's how many letters I need to put back in at the top. So if I had 5 letters come out of one column, I got to put 5 new random letters in that column. Does that make sense? And it's all, the reason it's all column based is because in the actual game, I'm using actual physics and gravity and forces and stuff to have the pieces fall. I'll actually show you the parts of the game that work. Not all of it does, but I'll show you that at the end. So that's thus the random. Again, I'm just populating it full of random crap, and I'm just keeping track of how many were supposed to go at the top of each column. And there's my stringify. Yeah, that's almost wasn't worth the function, but I did it anyways just to make it a little more readable. And then, oh yeah, I forgot that I had started on some logic here for finding potential matches. But I'm not going to talk about this too much because I can't remember whether or not this even works. So again, this is a work in progress. Literally, probably the hackiest talk I've ever given, but that's kind of more or less the point, actually. This is a prototype. This isn't meant to be my final code. I just hacked it together good enough to prove to myself that I could make it work and that the concept was sound. And then this just loops through and prints everything out. Everybody good with that? Anything to, I know I glossed over a lot of details, but again, the point is not so much that exact code as the concepts that you want to use for while thinking about, you know, how do I rapidly prototype things? You know, how can I think about a problem differently and approach it differently and maybe more simply than I tried the first time. Okay, so now we're going to look at the actual C# code. And I'm going to go through it real quick. Yeah, that's 127 lines. I guarantee you, we were talking in the multiples of hundreds. I don't even remember how bad the code was before, but multiple hundreds of lines of code.
You don't have a snapshot?
And it didn't even work. Well, yeah, if I felt like digging it up, but I wasn't really prepared for that. But I actually do have it in Git, so if I want to go back and get it,
somewhere
I can do.
we got it.
Yeah, so the idea being here, a list of elements is basically, I'm really not going to talk about this too much because this is almost heresy. I'm surprised the screen's not bursting into flames right now. 'Cause this is not Perl. What are you doing? I'm talking about C# in a Perl presentation.
At least it's multi-platform though.
Yes, that's true, with Mono. So basically, I'm just creating a list of elements. The way this interfaces, this is a class all by itself that just does the matching because I wanted that logic to be totally separate from the rest of the game. So basically, the game generates all the game objects and all the pretty little tiles or elements that you saw. Then it just passes that over to this class. And this class does all the converting it into character arrays and all of the mixing and matching and blah stuff you just saw in the other program. That way I keep all of that logic out so that for C# programmers that might be scared of regular expressions, they don't have to look at that class because it's all isolated by itself. So, yeah, exactly. Regular what? So, This is the part right here that actually converts it. You can see system convert to character. That's the part where I'm actually converting it from a game object to just a character. And I'm just, like I said, the trick I'm using is just chopping off the first letter of the name of each element, because each game object has the name of what type of element it is as one of its properties. So let's see if there's anything else in here that's terribly interesting. Again, we have to do a little bit of looping, but not nearly as much. Okay, so I separated row at line 42, and then line 67, we've got column, where we do basically the same thing, just in the other direction. So I could probably, might be able to refactor some of this code, but it was short enough that I felt like it was more clear to leave it separately rather than try to play funny tricks, just for what little code reuse I get, which is not a whole lot. And now you can see some things that start to look a little more like the Perl code. There's where I'm creating my regular expressions. Notice how horribly verbose it is to create regular expressions. At least it works, so I'm happy about that. And they have to be strings. They aren't bare words in Perl like they are in Perl. So that's one of the horrible things about doing regular expressions in languages that have to take them as strings, is the number of backslashes. Luckily, I didn't have backslashes, so I didn't need to. But when you're dealing with that, horrible amount of escaping of backslashes has to go on in the strings. It's nasty. I actually had a website that I used that you could put in the regular expression, and then it would, help you test it. Plus, it would give you the fully quoted string with everything escaped. So I could, once I got it working, just copy paste that into my code, and I'm good to go. So,
I'd
sorry?
like to see I'd like a link to it.
Oh, okay. I'll see if I can remember, after the talk, I'll see if I can remember the name of the site. I think I might have. Okay, so we've got some matches going on. And then we return, again, I've got convert range to coordinates again. So you can see basically overall it follows the same flow as what the Perl part did. The part you may notice that's missing is the permutation part. I haven't done that part yet at all in the game, so that's why that's missing. But I also, the reason I haven't done that yet is because I want to do my due diligence and see if there's already permutation library out there. There's no reason to re-implement that other algorithm if there's already a package that exists. That said, though, there are actually already modules on CPAN that do permutations, so don't think that algorithm's the only way to do it. I just wanted to do it that way in case I needed to, translate it into C#, just because I didn't know what was out there for C#. I didn't want to use any Perl modules. I just wanted straight Perl. That way, if I had to, I can convert it all to straight code and, not have any nonsense where I have to re-implement somebody's module on CPAN in C#. So didn't want to do that. So that's why I avoided that. Any questions? I know I really glossed over this, but it's C#, who cares? All right, one other thing here. I'm going to go back to this actually and do it without the more, just to give you an idea of how fast that was. You see, it's just like boom. And it's the same in C#. Well, you'll see it actually right now in the game, because that's actually the end of the slideshow. So now, bring up, I guess, a little advertisement. The engine I'm using is Unity. If you decide you want to dabble in game programming, it's a great way to do it. It's absolutely free, unless you've made, I think it's like $10,000 or something off of your game in a year. And it's like, dude, if I make $10,000 off of a game in a year, I'll buy 3 copies. It is fairly expensive, but that's what's nice is there also the pro version obviously has more features, but nothing that I've found, you know, that I would really miss. If you were, I'm sure if you were a professional, of course you would just go for the pro version, but I don't know what the heck I'm doing, so I'm doing half of it in Perl, so. Anyways, I'm just gonna hit the little play button here. Unfortunately, because of the lovely VGA, I messed up and didn't burn my adapter. Let's do this. Be a little easier to see. So do you see how those just kind of fell like that? The reason is because ultimately when the game gets developed, first of all, this won't be here. Second of all, that part that you saw will exist, but it's going to be off screen. The idea being that it generates everything, or it puts up all the random elements, and then there's literally an invisible block there that I toggle whether or not it blocks things. And once they all fell, then it, you know, disabled, and then they all just dropped. But if you notice, we could go through hundreds and hundreds of these if you want. I wouldn't recommend it unless you're incredibly bored. But this is a clean board. This has gone through, removed everything, and it actually does it in the start method, which is before it does any rendering at all. So literally by the time you saw it on the screen, it's already gone through every iteration and cleaned up that board. So you can see how fast it is. You didn't notice any real delay, right, between me hitting play and and if you did, most of that is just the speed of this machine. It's not a game machine, it's a boom. So I can sit there all day. So just remember that the reason that I'm stopping them all is because I don't want them to, I want them to drop in kind of an organic way, but not like you saw that one that was way behind the others. I don't want it to drop just down, so I want to stop them all first, and then them all kind of drop at the same time. So that's why I'm doing that. That's just a little, again, has nothing to do with Perl. That's just kind of the idea. And so the idea is that if we were playing this game, I would click on this, I would click on that, they would swap, and these would disappear, and I would get the points, it would drop down, and eventually I'd, you know, blast the other wizard in the face with the nice ball or something. So that's basically
Do you
it.
have the swap working?
I'm sorry?
Do you have the swap
No, I
working still?
don't. Well, see, of course, this is
Sorry.
another story. No, it's fine. It's fine. This is the story of programming, because of course in my old code that was horribly, horribly buggy in that part, I actually have the swapping working. Now, of course, it's not working. Well, I'll click on it and see what it does. You notice it actually highlights and it plays a little music if I have my speakers on. And then if oh, it does.
Yeah,
A
there
little
you
better
go.
than I thought. You can see it; those didn't drop, so it's not done yet. But
It did
it's
swap
better than
though.
I remembered. I didn't remember that I had that working.
Are you gonna make them fly away, the 3 of them?
Actually, that might be one of the things I do is just have a
They
do an
just
effect.
disappeared right now.
Yeah, right now they do just disappear. Again, my first goal is to actually complete it. Then I'll do the fancy stuff later. If I can actually just make it work and actually finish it, that will make me quite pleased. But anyways, that's my presentation. Any questions?
I see
Anything at all?
a neat post completion, kind of like this in a mashup with mine. So you have one of the pieces on the board is stick it down right behind it, and you try to swap that one and lose the game.
Oh.
But randomly.
Well, you know what's interesting too is that's what's so great about this implementation is it's very easy to change the rules of the game. You just change how your regular expressions and how they match. Yeah, And actually, I talked with a couple of guys here that have been doing game programming. Some of you guys probably know who I'm talking about. Yeah, exactly. They're literally, their heads almost exploded when I told them that this idea. So they were actually way more impressed with it than I was when I came up with it. So I figure it must at least be a pretty decent implementation because these guys are younger than I am and they don't have families, and so they have time to actually program games. And they've been working on games for years. And I just happened to be sitting next to them at lunch one day, and I, explained what I did, and they were like, "What?" They're like, "That's brilliant. You should write a paper." I'm like, This is probably as close as I'll get to writing a paper, this presentation. But anyways, I hope you enjoyed it.
And I'm gonna point out, I wasn't